If you want to provision and manage multiple Kubernetes clusters using Cluster API, you need a starting point, a central management cluster. By the end of this video, we are going to install, verify, and configure a lightweight Canonical Kubernetes management cluster that is fully ready to communicate with your external tools. Before we begin, you need to meet 3 strict requirements to follow along: a Linux machine, snapd installed on that machine, and sudo access. Once we run through this brief setup, your standard Linux machine becomes a production-ready control plane, laying the foundation for all your automated infrastructure moving forward. This diagram shows the relationship between our 2 main components. At the top is the management cluster, which hosts the Cluster API providers. Below it are the standard worker nodes. While worker nodes run your actual end-user applications, the management cluster's sole job is to oversee those nodes. Looking closer at the management cluster, we see the API server. Think of this as the front door. It acts as the central hub, processing all the incoming infrastructure requests. Right next to it is the scheduler. When a new workload arrives at the API server, the scheduler takes over, monitoring the incoming tasks and dispatching them to specific nodes based on what resources are currently available. This system relies on a continuous loop. The worker nodes constantly report their status up to the API server, and in return, the API server sends back new instructions for the workers to execute. Understanding this communication hierarchy helps clarify exactly what we are about to do. The installation commands we are going to run are specifically designed to stand up and secure this API server and scheduler. Let's get started. Go ahead and open your Linux terminal. This image shows the exact command we'll use to install Canonical Kubernetes. We are going to type sudo snap install k8s, followed by the classic flag, and channel equals 1.35 classic stable. That classic flag is mandatory. It grants the snap package the system-level access it needs to actually run container workloads on your machine. Make sure you prepend the command with sudo. Permission denial is the most common reason this installation fails early on. With the software installed, we need to initialize the control plane. Run sudo k8s bootstrap, and you will see the startup logs begin to scroll. Going back to our blueprint, this bootstrap process is the exact moment where your API server and scheduler are spun up and configured. The bare metal software is now fully active. We can shift from the installation phase into critical system verification. We need to verify the cluster is healthy. Look at this terminal execution. We run sudo k8s status-wait ready. Notice how the cursor appears paused on a blank line. This temporary hang is normal behavior. The system is just waiting for all the internal components to report a healthy status before returning the prompt. Do not attempt to extract any configuration files before this status command successfully completes. Moving too fast here will break the setup. Once the prompt returns, we need to generate our kubeconfig file. This file acts as a secure access badge, allowing your external tools to authenticate with the new management cluster. First, let's avoid a common folder not found error. Create the hidden kube directory by running makedir-p //kube. Then, export the configuration using the output redirect command. Run sudo k8s config, add the greater than symbol, and point it to the new folder path. By successfully exporting the kubeconfig file to the correct path, your management cluster is now securely bridged to your external command line tools. The core setup is complete. Your Canonical Kubernetes management cluster is now operational. The API server is active, the scheduler is listening for workloads, and your access badge is properly positioned for your system to use. If you want immediate, tangible proof that your control plane is running, type k8s kubecontrol get nodes in your terminal to see your cluster responding. Your immediate next steps from here are to install clusters.CTL and initialize your Cluster API providers so you can begin dynamically provisioning worker nodes. You now possess the required control center foundation to scale your infrastructure exactly how you need it. Check out the next video in this series to start deploying your first workload.